Hello class, our topic today is going to be on linear momentum. Now in our previous class, we learned that motion is actually caused by unbalanced forces. Now linear momentum actually tries to discuss the influence of these unbalanced forces upon bodies, the motion of the bodies, and the laws governing such motion. That means at the end of this lesson, we should be able to state and explain Newton's three laws of motion. So, show that force is equal to mass times acceleration. 3. Solve simple problems involving Newton's law of motion. 4. State and explain the law of conservation of linear momentum. And then finally, give some applications involving Newton's law of motion. Now let's go to momentum. Now what is momentum? Now momentum of a body can actually be defined as the product of its mass m and velocity v. The product of its mass m and velocity v. That means momentum is equal to mass times velocity. Now since the unit of mass is kilogram and that of velocity is meters per second, means that the unit of impulse will be kilogram meters per second. Now a body of mass 2 kilograms moving with a velocity of 10 meters per second is going to have the same momentum as a body of mass 5 kilograms moving with a velocity of 4 meters per second, since momentum is mass times velocity. Now momentum is actually a vector quantity. How can you remind me what a vector quantity is? Okay, yes. A vector quantity is any quantity that has both magnitude and direction. Now momentum has magnitude, which is the mass and the velocity, and then in the direction of the velocity. Now let's take a very simple problem on this. Now listen very carefully. Now, a body of mass 3 kilograms moves with a velocity of 10 meters per second. Now calculate the momentum of the body. Now if a body of mass 3 kilograms moves with a velocity of 10 meters per second, now calculate the momentum of the body. Now since momentum is mass times velocity, and from the question, the mass is 3 kilograms, while that of the velocity is 10 meters per second. So since momentum is equal to mass times velocity, that means that it will be 3 kilograms times 10 meters per second, which will give us 30 kilograms meters per second. I hope it's clear. Alright. Now let's go to impulse. Now impulse has to do with collision. Now impulse is associated with collision. Now what is collision? Now let's take an illustration. Now when two bodies collide, now each receives an impulse or a blow. That is what we call collision. So that means impulse is actually the product of the average force acting on a body and the time during which it acts. The product of the average force acting on a body and the time during which it acts. That is what we call impulse. So it means that impulse is equal to force times time. Now since the SI unit of force, now what's the SI unit of force? Okay, Newton. What of that of time? Alright, second. So it means that impulse will be equal to force times time, which is what? The SI unit will be what? Of impulse will then be Newton second. Now impulse is also a vector quantity. Now let's take a very simple question on this. Now if a stationary ball is hit by a force of 50 Newton at a time 0.03 seconds. Now what is the impulse experienced by the body? Now since impulse is equal to force times time, now from the question the force is 50 Newton and the time is 0.03 seconds. It then means that impulse will be 50 Newton times 0.03 seconds, which will give us 1.5 Newton seconds. So the impulse experienced by the body will be 1.5 Newton seconds. I hope it's clear. Any questions so far? Alright. Now let's go to Newton's 3 laws of motion. Now, since we know that motion is actually caused by unbalanced forces, now Newton's 3 laws of motion actually try to describe the relationship between force and motion. Newton's 3 laws of motion try to describe the relationship between force and motion. Now let's go to the first law. Now Newton's first law of motion states that every object continues in its state of rest or uniform motion in a straight line unless acted upon by external forces. So it means that if a body is at rest, it will remain at rest unless an external force acts on it. Now let's take an illustration, a very simple one that we experience. Now, if a book is placed on top of a table, it will remain at rest unless something pushes it or pulls at it. So that means in the absence of an external force, a body can move forever with the same velocity. Now, the tendency of bodies at rest or linear motion in the absence of applied force is what we call inertia. The tendency of bodies to be at rest or linear motion in the absence of applied force is what we call inertia. So that means that inertia is inherent in bodies at rest. So the more massive a body is, the more inertia it has. Now let's take this example. Now passengers in fast moving vehicles tend to move forward when the car suddenly stops, and then backward when the car speeds up. Now since there is little or no restraining force, now that's why seat belts are used to provide the restraining force. Seat belts are used to provide the restraining force. Now from there we go to Newton's second law of motion. Now Newton's second law of motion actually states that the rate of change of momentum is proportional to the impressed force and takes place in the direction of the force. That means force is proportional to change in momentum over time. Now since we know that momentum is defined as mass times velocity, it then means that force will be equal to mv minus mu over the t, where m is the mass of the body, v is the final velocity, u is the initial velocity, and t is the time taken. But we know that acceleration is equal to mass over acceleration is equal to velocity over time. Now since acceleration is equal to velocity over time, it then means that force will be equal to mv minus mu over t, which will now give us force will now be equal to ma, since acceleration is equal to v minus g over t. That's the final velocity minus the initial velocity over the time. So force will be equal to mass times acceleration. So it then shows that this is the second law of motion actually tells us that force is always proportional to change in momentum with time, and then also that force is also equal to the product of force of mass and what? Acceleration. Alright. Now from there we move to, now let's take a simple problem on this. Now if an unbalanced force of 20 Newton acts on a mass of maybe 4 kilograms, now what is the acceleration? Now since we know that force is equal to mass times acceleration, now from the piston, the force is 20 Newton while the mass is 4 kilograms. It then means that acceleration will be equal to force over mass, which is equal to 20 over 4, which will give us 5 meters per second. So the acceleration will be 5 meters per second. I hope it's clear. Is there any question so far? Alright. Now let's go to Newton's third law of motion. Now Newton's third law of motion says that to every action there is an equal but opposite reaction. So every reaction there is an equal but opposite reaction. Now it then implies that if a body A, which has a force of maybe Fa, acts on a body B, then the body B also will have a force of Fb and act on the body A. Now, Fa and Fb actually equal in magnitude but opposite in direction. Now, since Fa and Fb are vector constants, so it don't mean that Fa will be equal to minus Fb, where Fa is the action force and Fb is the reaction force. Now let's take an illustration, a practical one. Now, if you hit the wall with your head, if you hit the wall with your head, now your head will exert a force on the wall, and at the same time, the wall exerts an equal but opposite force on your head, which is now the pain you feel. Which is the pain you now feel. Now from there we go to conservation of linear momentum. Now actually conservation of linear momentum actually has to do with a closed system. And what is a closed system? A system whereby no external forces will act. Now the only forces acting are those due to collision. And the principle of conservation of linear momentum actually states that in any system of colliding objects, that the total momentum is always conserved as far as there is no external forces acting on it. And then 2, that the total momentum is constant. And 3, that the total momentum after collision is equal to the total momentum before collision. Now let's consider a body of masses Ma and Mv, and then on final velocity Va and Vb, and initial velocity Ua and Ub. Now when these two bodies collide, now Fa will have an equal but opposite force to that of Fb, which obeys Newton's third law of motion. So that means Fa will be equal to minus Fb. But since we know that force is proportional to change in momentum, so that means that Fa will now be Fa bracket open Va minus Ua over C, which is equal to minus Mv bracket open Vb minus Ub over C bracket close. Since Fa is equal to minus Fb. Now from there we move to applications of Newton's 3 laws of motion. The applications. Now let's take a very good one that we all know. A very practical one. I hope you know physics has to do with what we do every day. Now, why walking is possible. Now when a person walks, now a person actually walks by pushing his or her foot against the ground. And then the ground also exerts an equal but opposite force back on the person. Now it is that force on the person due to the reaction of the ground that actually helps him or her to push forward. I hope it's clear. Now we have some other applications by the recall of guns. Now so far, do you have any questions so far you can ask? Okay. Okay, no questions. Alright. Now that will be the end of today's lesson. Okay, I hope that is clear. Okay, see you some other time. Thank you. Bye.